Hey sleepyheads, and welcome to Brainwaves. Ever wondered what your brain is up to while you're catching those Z's? Today, we're exploring the nighttime symphony of nocturnal magic of how your brain keeps the body grooving. Even when you're in dreamland, the command center, the brain's night shift. As the lights dim and your eyes shut tight, your brain takes center stage. The dynamic duo, brainstem and hypothalamus in the sleep saga. The command center for this nighttime extravaganza is the brainstem and the hypothalamus. Alright, imagine your brain as the captain steering the ship of sleep. And at the helm you have the dynamic duo, the brainstem and the hypothalamus. These two are the unsung heroes orchestrating the symphony of your slumber. Let's dive into their roles and see them in action. The brainstem, director of the sleep show. The brainstem, located at the base of your brain, is like the chief director of the sleep show. It's divided into three main parts: the medulla oblongata, pons, and midbrain. Together, they play a crucial role in regulating fundamental life functions, including sleep. Heartbeat harmony, the medulla oblongata. First up, let's talk about the heartbeat harmony led by the medulla oblongata. This is the brain's DJ for your heart. The medulla oblongata ensures that your heart maintains a steady rhythm during sleep, making sure it stays in the rhythm even when you're deep in dreamland. It's like a smooth jazz session for your cardiovascular system, ensuring that your heart keeps the beat without missing a note. The medulla oblongata is the lowermost part of the brainstem, seamlessly transitioning into the spinal cord. It houses the cardiac center, a cluster of neurons dedicated to regulating the heart rate. The medulla constantly monitors the levels of oxygen and carbon dioxide in the blood. When it senses a need for adjustment, it sends signals to the heart through the autonomic nervous system and parasympathetic branches of the autonomic nervous system. Sympathetic stimulation increases heart rate, while parasympathetic stimulation slows it down. When you're in a deep sleep, your body's oxygen needs decrease. The medulla detects this and ensures that your heart beats at a slower, steady pace, conserving energy and promoting restful sleep. Within the medulla, you'll find the respiratory centers that control breathing. The medulla orchestrates a balance between the sympathetic and parasympathetic branches of the autonomic nervous system. The medulla generates rhythmic breathing patterns by coordinating the contraction of respiratory muscles, like the diaphragm and intercostal muscles. During sleep, especially in the deeper stages, the medulla ensures that your breathing becomes more rhythmic and regular. It's like a seamless ballet of breath, where each inhalation and exhalation occurs with precision. Another crucial function of the medulla is its role in regulating blood pressure through the vasomotor center. The medulla adjusts the diameter of blood vessels, influencing blood pressure. It achieves this by altering the degree of constriction or dilation as you transition through different sleep stages. The medulla ensures that your blood pressure remains within a range suitable for each stage. It's like a silent guardian adapting to the body's needs without disturbing your peaceful slumber. In essence, the medulla oblongata acts as a vigilant conductor during your sleep symphony, adjusting the beats of your heart, the rhythm of your breath, and the flow of your blood to create a harmonious and restorative nighttime experience. The breathing ballet, pons and medulla. Now, the breathing ballet featuring the pons and medulla. They make sure your lungs pirouette gracefully through the night, inhaling and exhaling with the precision of prima ballerinas. It's like a lung waltz to the soothing melody of your dreams. Scene 4, the sleep cycles, REM and non-REM. Your night isn't a monotonous snooze fest. It's a dynamic show of sleep cycles. The brain moves through different stages. From non-REM to the star of the show, REM, rapid eye movement sleep. It's like your brain's own Broadway production, complete with thrilling scenes and plot twists. Example, moving through the sleep stages, each with its unique flair. Scene 5, Dreamland decor, the hippocampus. As you venture into dreamland, The hippocampus is your set designer. It arranges the scenes of your dreams, creating a fantastical realm that your mind explores. It's like having a Hollywood studio in your head, producing blockbuster dreams every night. Temperature tango, hypothalamus again. The hypothalamus, often dubbed the body's internal thermostat, plays a key role in regulating temperature, making sure you stay cozy under the blankets. The hypothalamus receives information from thermoreceptors throughout the body, both in the periphery, like the skin, and the core, internal organs. It also monitors the temperature of blood circulating through its own tissues. When the hypothalamus detects a shift in temperature, it sends signals through the autonomic nervous system to various effectors to initiate responses. The hypothalamus can activate the sympathetic nervous system, which might cause responses like shivering or sweating to adjust body temperature. It can also influence blood vessel dilation or constriction to regulate heat exchange. As you prepare for sleep, your core body temperature naturally decreases. The hypothalamus plays a role in orchestrating this cooling process, helping signal to your body that it's time to wind down. The hypothalamus is also involved in the regulation of melatonin, a hormone that plays a crucial role in sleep-wake cycles. Melatonin is primarily produced in the pineal gland, a small pinecone-shaped gland located deep within the brain. Control of REM sleep. During REM sleep, the hypothalamus remains active, sending signals to the cortex to generate dreams. The thalamus, a brain region involved in sensory processing, also becomes active, transmitting sensations like images and sounds to the cortex, which contribute to dream experiences. Connection to REM sleep behavior disorder, RBD. Dysfunction in the hypothalamus can lead to REM sleep behavior disorder, where individuals physically act out their dreams due to a lack of normal muscle paralysis during REM sleep. Initiates and maintains REM sleep. Contributes to dream content, and plays a role in preventing physical movements during dreams. As daylight fades, the pineal gland ramps up melatonin production. Control of REM sleep. Exposure to light, especially natural sunlight, suppresses melatonin production. This decrease in melatonin during the morning helps signal to the body that it's time to wake up and be alert. Midnight snack patrol. Ever feel hungry at midnight? Blame it on the ghrelin brigade. These hormones, under the command of your brain, might send you on a quest to the fridge. Imagine it as your body's little hunger messenger sending signals to your brain that it's time to eat. Ghrelin is made in your stomach, specifically in the lining of the stomach. Ghrelin levels usually go up before you eat, so when your stomach is empty, ghrelin is released, telling your brain, hey, it's time to refuel. Once you start eating, ghrelin levels drop. It's like the message has been received, your stomach is full and the hunger signal starts to quiet down. Ghrelin might influence your cravings, making you more interested in certain types of food, especially when you're hungry. It's like a little guide nudging you to explore different types of food to meet your body's needs. Ghrelin follows a kind of routine. If you usually eat at certain times, your body gets used to that schedule, and ghrelin tends to rise before those anticipated meal times. So the next time your stomach rumbles, you can thank ghrelin for sounding the hunger alarm. In a nutshell, it's your stomach's way of saying, time to eat. Conclusion, the encore and morning wake-up call. And there you have it, the nighttime symphony orchestrated by your incredible brain. As the night draws to a close, your brain begins the morning wake-up call, preparing you for a brand new day. So, the next time you hit the hay, remember, your brain is throwing a sleep party and you're the VIP guest. Thank you for watching. And don't forget to like, share and subscribe for more bite-sized insights into the wonders of our brains. See you next time.